Hello and welcome to Algebra 2 CST release question number 40. It says there are two properties with the following. How about there are two numbers? There we go. There are two numbers with the following properties. Number one, the second number is 3 more than the first number. And number two, the product of the two numbers is 9 more than their sum. So to me it looks like we're going to be making some equations and translating these sentences into mathematical sentences, which are equations. So which of the following represents possible values of these two numbers? And yes, we could use the answer choices and just try those and test those against these two things, but I want to be able to figure this out even if the answer choices weren't here. So how can I go about doing that? Well, let's break this down into its parts. So the phrases, let's see here, we've got the second number. Let's refer to that from here on out as y. The second number we'll call y. The first number, let's call that x. And then it says it is. So when you see that word, mathematically that means it's equal to. So if it is, it's equal to, and then it's 3 more than, so it's going to be plus 3 somewhere in there. So the second number is y is equals 3 more than the first number. So that's another way to write that is x plus 3. We could also write 3 plus x. The commutative property of addition says we could add those in either order. And then number 2, the product. With the product, I'm not going to write x because that looks like, even though it means times, it looks like my variable. So when I see that word, mathematically I'm thinking I'm multiplying or timesing these two things together. So the product of the two numbers, that's going to be the x and the y. So product of the two numbers, so I'm thinking x times y is or equals 9 more than. When we see that, that's again like a plus 9 or a 9 plus. I can think of it either way. 9 more than their sum. And so the sum, I'm thinking I'm going to be adding things together. And so let's make that into a mathematical sentence with the variables and the numbers. So the product of the two numbers, x times y, is or equals 9 more than their sum. So that'd be 9 more than their sum would be x plus y. Those two things added together. And so I can write this in a more simplified way. I can write that as x, y equals, I guess I'm not really that much more simplified, but I can get rid of the dot in between, and I can just get rid of the parentheses as well. 9 plus x plus y. Okay, so from there, where can I go from here? So I've got two separate equations. This was from part 1, this one was from part 2. So I see that y equals this. I'm going to be using this one, and I'm going to be using this one. Since y equals that, I can take that, use substitution, and plug in wherever I see y here. I see a y here, and I see a y here. I'm going to plug in x plus 3 in place of that. And so let's do that in the next step. And so instead of writing y, I'm going to write x times x plus 3 equals 9 plus x plus, and replacing again y with x plus 3. So let's simplify this. I'm going to distribute that x to both parts. I will have x squared plus 3x. This would equal 9 plus, I see 2 x's right there. 9 plus 2x plus 3. I could have actually combined the 9 and the 3 together as well. So why don't I do that in this step? And that would be 12. From here, I can subtract 2x from both sides. That's gone, that's gone. I can also subtract 12 from both sides. And why I'm doing that is because I want to get one side equal to 0. So I'll have x squared, 2 went a little long there we go. X squared plus x minus 12 equals 0. Now you could use the quadratic formula here to solve for x, but it's not really necessary because we can just factor this out. This one's factorable. We can think of two numbers that multiply together to get negative 12, but add together to get positive 1. Remember, it's like there's an invisible 1 right there in front of the x. And so what numbers will do that for us? It should be 4 and negative 3. Multiply them together, you get negative 12. Add them together, and you get 1. So we have x plus 4 and x minus 3 is equal to 0. And so from there, we can solve for x. I know based on this, I could split this apart into two separate parts. I could have x plus 4 could equal 0, or I could have x minus 3 equal to 0. Remember, if one part or one factor equals 0, it doesn't matter what that other factor is. 0 times who cares what that would be would still equal 0. Same thing with this. If this part were equal to 0, 0 times who cares what that would be would still equal 0. So from there, we can think of this as two separate problems. I can subtract 4 from both sides, get x equals negative 4 as one possibility, and I can add 3 to both sides here, and get x equals positive 3 as another possibility. And so this is the value or possible values for x. But we need x and y, and so we need two possible values. We need both the values. So we need to go back here, up here, into either this one or this one. This one's going to be a lot easier to deal with though. So I'm going to be taking this and combining it together with this to come up with two possible pairs of solutions. So for x equals negative 4, I'll put that right here, and for x equals 3, I'll put that over here. So if I plug in negative 4 into this equation, I would have y equals negative 4 plus 3, meaning that y would equal negative 1. And so for x equals negative 4, y would have to be equal to negative 1. If I plug in 3 for x, y would have to be 6. And so this looks like two possible combinations. A good idea to check both of these into both equations. We just checked it in this equation, but let's see that both pairs still work out in our second original equation. So for negative 4 times 1, here, negative 4 times 1 would be negative 4, and it looks like this would be negative 4 minus 1, so I'd have negative 5. Does negative 4 equal positive? That would be 9 minus 5, which would be 4. Does negative 4 equal 4? No. So it wouldn't equal. So I'm thinking about that wrong. Just a second. Hold the phone. Go back just a moment. So I'm thinking negative 4 times negative 1. That would be positive 4. That's where I'm going wrong with that thinking. So is that equal to 9 plus negative 4 minus 1? This would be 9 plus a negative 5, or in other words 9 minus 5, which would be positive 4. And then this would also be positive 4. So positive 4 equals positive 4. That's a possibility. That checks out. And so let's do that for the other pair. Let's see what we got. Let's see if that works out. And so, going way too far with that. Let's bring that back. Come back to me. There you are, y equals 6 and x equals 3. Okay, so x equals 3, y equals 6. Plug in 3 times 6. Does that in fact equal 9 plus 3 plus 6? This would be 18. And so would this side. That would also be 18. And so I see that checking out as well. That's good to go. But which one of these pairs actually is one of our choices here? Do I have a pair that includes negative 4 and negative 1? Yes, I do. Choice B includes that. Do I have a pair that includes positive 3 and positive 6? No, I don't have a pair that includes that. And so the correct choice of what is here is choice B. There's actually two possible answers. You could have negative 4 and negative 1, and that would satisfy both of these things at the same time. You could also have 3 and 6, positive 3 and positive 6. That would satisfy both of these things at the same time. The only one that's actually here, though, is choice B.